Hi, this is Dr. Anas Osama, and today I'm going to give you an introduction about the chapter Electrolysis. Before we go deep into the chapter, first we need to know the definition of electrolysis. The definition of electrolysis is it's the breakdown of ionic compounds when molten or aqueous using electricity. Okay, so we should take care that it's the breakdown of an ionic compound and it should be either molten or aqueous. Okay, why should it be molten or aqueous? Because we know that ionic compounds only conduct electricity when they are in the liquid state, molten or aqueous, so that the ions are free to move and be able to carry the charge. Okay, so our goal is that if we have an ionic compound like sodium chloride, what we need to do is to break down this ionic compound, sodium chloride, into sodium and chlorine. Okay, so before going, how do we do this? First, let's see how was the ionic compound formed. The ionic compound sodium chloride was formed by a chemical combination between a sodium atom and a chlorine atom. We know that sodium is in group 1, which means that it has one electron in its outer shell, and we know that a chlorine atom is in group 7, which means that it has 7 electrons in the outer shell. And since sodium atom has one electron in its outer shell, it loses its electron and giving it to the chlorine atom, which gains the electron. So the sodium atom loses one electron and giving us a sodium ion. This is what happens during the formation of the ionic compound sodium chloride. And also the chlorine atom gains one electron, forming the chloride ion, which is negatively charged. Okay, now that we have the ionic compound formed, what we need to do is to oppose this change. How can we oppose this change? For the chloride ion to return again to a chlorine atom, it needs to lose this electron and return it again to the Na. So the chloride ion will lose the electron. And the sodium ion will gain its electron again. And when it gains its electron, it will form the sodium atom, and now the ionic compound is broken apart. Okay, this is what happens during electrolysis. Okay, let's see exactly how this happens. If we have, this is the cell, this is the negative pole and this is the positive pole of the cell, and then we are having the wires, which are usually made of copper, since copper is a good conductor of electricity and it's ductile and malleable. And then we have the electrodes. We have the two electrodes. This one is the negative electrode, which we call it the cathode. And this one is the positive electrode, which we call it the anode. And what's remaining now is the ionic compound or the conductor or the electrolyte of the electrolysis. And electrolyte is the aqueous or molten ionic compound that undergoes electrolysis or that conducts electricity. So the molten aqueous compound that conducts electricity. Okay, so let's say the electrolyte in this case is molten sodium chloride. We said that the sodium chloride will be broken apart. This is sodium chloride. It will be broken apart into sodium and chlorine. Let's see how this happens. This molten sodium chloride contains sodium ions, which are mobile because it's in the liquid state, and chloride ions, which are also mobile in the liquid state. What happens is that the chloride ions are attracted to the anode. Okay, and then what will happen at the anode? The chloride ions at the anode, we said that the chloride ions already they gained one electron, and to return again to a chlorine atom, they need to lose the electron. So the chloride ion will lose the electron, returning again into chlorine atom. But take care that some elements are diatomic, such as chlorine. When uncombined or when it's an element, it should be diatomic. There is no chlorine atom alone. It should be diatomic. So the chlorine atom will add a 2 because it's diatomic. Then we need to balance the equation. So we'll place a 2 beside the chloride ions. And since one chloride ion loses one electron, the 2 will lose 2 electrons. So the chloride ions lost the electrons at the anode. Okay, it's better to write this ionic half equation like this. 2 chloride ions gives us chlorine plus 2 electrons. Yeah, simply we switched or placed the electrons on the other side. Okay, now the chloride ions, after it lost the electrons, it forms chlorine element at the anode. So we'll observe some bubbles or a gas, green gas at the anode. Now the electrons will travel through the circuit, through the wires, going to the cathode. And since sodium is positively charged, it will be attracted to the cathode. The sodium ions at the cathode will gain this electron, because we said for the sodium ion to return to a sodium atom, it needs to gain the electron, so it gains the electron, forming a sodium atom. So we can say that the sodium is formed at the cathode and chlorine is formed at the anode, and this is how we broke up the ionic compound. Finally, we need to say that the electrodes materials should have some properties. Number one, of course, they should be good conductor of electricity to transfer the charge. Good conductor of electricity. And number two, which also highly important, is that they should be inert or unreactive. Why the electrodes need to be unreactive? Actually, they need to be unreactive because when sodium element is formed at the cathode, if the cathode is reactive, it can react with the sodium, forming another compound, making this experiment useless. Or the chlorine, if the anode is reactive, the anode will react with the chlorine, forming another compound, so that I won't have chlorine separated as an element. So the electrode should be also inert, plus it should be good conductor of electricity. We have one metal and one non-metal used for electrodes. The metal is platinum. This is the metal used as an electrode. And we have graphite, which is the non-metal, also can be used as electrode because it has the properties we just mentioned. Okay, we finished the introduction, and see you in an introduction of another chapter.